So okay. All right. Okay. We are in chapter 9. This week we'll do another 2 chapters and proceed forward. So this chapter is all about HA, fault tolerance, and protecting data. Broken up into 5 pieces. Vsphere has quite a number of ways to protect your data, to protect your virtual machines to always stay on. Because again, the whole point of vSphere vCenter is to keep systems up. It's the infrastructure level. It's not what users interact with. It's the layer beneath them. So the stuff that we'll talk about is the things that reduce downtime, that if there's an unplanned downtime or any need to recover, this is where the things that are already built into vCenter come into play. By making it highly available, which was HA high availability, we can keep our servers on no matter what, our virtual machines on, and any services that we offer through them on no matter what, along with native backup and redundancy throughout our data center or data centers. High availability, or HA, uses multiple ESXi hosts that are configured as a cluster in order to provide that rapid recovery from any outages and keep virtual machines running all the time. With HA, in this example, we have 3 physical hosts and 1 vCenter server. If a host goes down at any point, let's say this first host, if this first host goes down for whatever reason, the machines within it will not be lost. Nobody will feel the change. Instead, these virtual machines will automatically run on the other hosts. So while we can service this host, figure out why it went down, these other 2 will take the load of virtual machine A and B, and our users will never know the difference. If we have VMware tools installed, which we should, we'll be able to know which virtual machine goes down by their heartbeat. And vSphere HA will be able to reset that virtual machine for us. So we don't even have to do anything about it. It'll let us know that it noticed that virtual machine D stopped working, so it restarted it for us. With VM component protection, we can have that same level for an application within a virtual machine. Further ensuring that services are up all the time for our users from our data center. So with VMCP on, you'll be able to detect any data store accessibility failures. And this can range from permanent device loss, like let's say a power outage. And if all paths are down, it it figures out what's another way to get systems up if possible. With high availability, we have ways to get systems up in case they lose network access. There could be an alternate way for the host to get back on the network just in case. And again, if the host itself is completely down, its virtual machines can just move off to another host and continue functioning. So high availability depends on heartbeats, which are basically pings. If you want to think of it that way, it's basically a ping between vCenter and either the application, the host itself, or the virtual machine to see that it is on. Ideally, you want the heartbeat network to be a totally different network from your management and from everything else. Because if those heartbeats take too long to return, then vCenter is going to assume the system or the application or the VM is down and do something about it. So you definitely want to have a different network for your heartbeats and ensure that that network is redundant should something go wrong. You can team NICs up so that there's different ways to get those heartbeats out on the network. Again, in case a NIC goes down, the other one can take over, and we still know that the system is actually up, but there's something wrong with this specific NIC. So it doesn't jeopardize the entire infrastructure, but we can narrow down quickly where an issue may lie. It is possible to use separate management networks. You can definitely do redundancy this way as well. Just make sure that if you are enabling, you're going to set up a heartbeat network, make sure that it is redundant, because that's going to be essential to ensure your data center is up all the time. The architecture for high availability starts with vCenter, of course, having its management network and a group of hosts connected together into what's called a cluster. These clusters will send each other those heartbeats to ensure that the systems are alive. And they'll all report back to vCenter with yes, they are on, or no, they're not. Data stores can also send heartbeats out. That can be another way to detect a network outage. vSphere high availability responds to any systems going down or a network failure. In regards to the data store, we can handle the absolute or the permanent outage. When a host goes down, and by down, it just simply means it's not responding, it's not sending those heartbeats and not responding, then the hosts begin to identify what could it be, and see if they can resolve by either moving things around or sending a message out to the administrator. They try to figure it out on their own first. If a master system goes down or the primary system goes down, then the other two will also detect the same and try to figure out, okay, who will be assigned the master now, and to keep each other going. if it's detected that a host is not receiving any heartbeats, there's nothing coming in or out of it, it's just assumed that the host is isolated. Those virtual machines will be dealt with, and life moves on. Alerts are sent out, and we get alerted that, hey, this server is down. The host isolation is the worst, because with host isolation we have to, go to it, physically go to it to find out why the network went down. This is why it's important to have redundant heartbeat networks and implement any way to reduce isolation. Because when this host goes down completely, when we can't reach it, then no tool can get to it. We can't SSH into it. We can't remote into it if it's completely down. So the last thing you want is host to become isolated. Now, virtual machines are able to survive these outages. Of course, you don't want these outages to happen, so you do everything you can, like having good switches, having good array configurations, having a good power backup options. But we can't plan for, or we can't have everything for any possible situation. We do our best to plan and prepare and use the tools that are provided by Vsphere to keep our systems up. VMCP will help you keep your VMs working even when an outage or issue occurs, and prevent them from getting corrupted. So like I said, vSphere high availability needs to be as part of a cluster. You have to do that first. You're going to need between 2 and 64 hosts together. All of them have to have static IPs, or at least the address should be the same per every reboot. They all should have at least one management network in common in order to communicate with each other. And ensure that you have VMware tools installed on all VMs. It's pretty easy to set up. There is in the edit cluster settings, there are options to enable host monitoring, to turn on high availability. You'll get these further options to dig deeper. You can set what to do for failures with like data stores. If we're monitoring virtual machines, we can enable that to either the VMs or the applications as well. We choose the heartbeat data store. It'll be used just in case our management network fails. That will be the backup place where all of our hosts will continue to ping and say, I'm alive, but the network is down. The admission control is a setting that's pretty essential. It'll ensure that both sufficient resources are available and provide failover for you. So here's an example of 3 systems. They are not all equal, but we can put them together in a cluster, and our total capacity will be 24 gigahertz and 21 gigabytes of RAM. With this reservation working out for all of our applications and virtual machines. Here is an example with admission control, having 3 different hosts. with a couple of virtual machines. And this example, we have a total of 10 slots. We have 2 gigahertz CPU and 2 gigahertz memory. Our failover capacity is 1 host, so we can live with one of these hosts dying. We can't live with 2 dying. If host 1 fails, 6 slots remain in the cluster, which is sufficient for all the 5 VMs powered on. Again, if we lose 2 of our hosts, then we don't have enough slots to keep all our VMs running. If we reach that point where 2 hosts go down, then any other VMs won't be able to power on because we don't have enough resources to power them all on. So this number is important to state. How much performance degradation will we allow before we can no longer keep our system up? You can set advanced options for the HA cluster. For example, forcing them to not use the default isolation address or ping alternate isolation addresses and so on and so forth. You can do that in the advanced options. If you use orchestrated restart, you have these conditions that you can use along with a priority tier. Again, always ensuring that our data center will be up no matter what. The orchestrated restart is sitting in failures and responses a little further down under host failure response. So you can put the default priority for our VMs and any conditions for turning them on or keeping them off. So this will allow our VMs to be able to stay up, or depending if we don't have enough resources, what will stay on and what won't. We can pick and choose. So for example, in order for A to turn on, it depends on B and B depends on C, but since these two aren't necessarily dependent upon each other, then we can have something like B doesn't get restarted when C fails over. But A and C will restart in parallel together. Again, to keep our services up. Host monitoring is that essential portion. Setting this up properly will prevent unwanted attempts to fail over virtual machines. The resource allocation will tell you how much you have overall and how much we're saving just in case we have any issues. And then, of course, you can see the status of your cluster. Fault tolerance is next. Fault tolerance is what ensures that we have zero downtime, zero data loss, and no loss of TCP connections, even when we have a VM moving over to another physical host in a cluster. So we can handle up to 8 virtual CPUs and 128 gigabytes of memory. We can handle up to 4 fault-tolerant VMs per host with no more than 8 vCPUs between them all. Of course, vMotion has to be used between the primary and secondary VMs. That has to be supported. in order to enable this, we have to be able to make a secondary copy of all the disks. So both devices have to have enough storage to do that. This does handle things like thin provision, thick provision, lazy and eager zero. Works with DRS and works with vSAN. So where Vsphere HA is required for fault tolerance, it'll handle the restart of any failed VMs, and its fault tolerance DRS will select which host will run the primary and secondary VM when it's power on. DRS does not automatically migrate any fault tolerant virtual machines. In order to enable fault tolerance, we have to have a copy of everything. So our two systems who are using fault tolerance will have a copy of the VMX file of the VMDK files in each of their data stores. If there is a change in the primary machine, that's not processed in the secondary. The memory is just updated. So as whatever happens in our primary system, the contents of memory gets moved over to the secondary. In case we have to do an instantaneous flip, then the memory is all up to date on both sides, so we can continue working no matter what. Using fault tolerance, that second VM is created in the secondary host, and then the things like memory and everything else is copied between the two. So you definitely need to make sure that your backbone, your network backbone is strong in order to copy RAM quickly from one system to another. There is the symmetric multiprocessor in order to check, to maximize that workload performance. So it'll take the time to check between the two and make sure that everything is fine up to this specific point. Between the two hosts, there can be a shared file that will prevent any change. That way it's the same UUID between the two systems. If you see a .ft generation, then we have what's called a split brain condition, which basically means whatever process is happening, it's occurring on both hosts, and the information is being stored in one location. Kind of like round robin networking. So these VMFT files, which you'll see in a shared data store between the two, is basically a meta file. It contains the two UUIDs and their VMX paths. That way both systems know where is the information. So if and when they have to fail over quickly, nothing is lost because everything is already pre-pointed just in case we need to make that switch. Enable fault tolerance is in the VM. So you would right-click a VM, go to fault tolerance, and then turn it on. Lastly, we have replication for this chapter. This is an extension of vCenter server, providing you that replication and recovery for your host and VMs. It's an appliance that has everything you need to perform the replication all in one. It can move VMs from a source site to a target site monitor and manage their replication status, and do any recovery at the target sites. So this is what you would use to, for example, make a hot or warm site. Should your hot site go down or your main site go down, you have 2 sites or up to 2 sites that you could easily activate because you're moving or you're replicating data from one data center to another. Deploying the appliance is an OVF. Once it's in, then you'll have these options to replicate. And then we can enable it and say, hey, we want to keep 3 instances per day for the last 5 days. So we essentially create these point-in-time backups. When something goes wrong and we don't have a snapshot for it, but we have replication, we can easily use replication in order to recover an image to the target site. We can also use storage API in order to communicate with our storage that could be off host to do LAN-based backups. So it's great if our ESXi's resources become overloaded, we can use this process to get our storage mounted, do whatever we need, sent off to a backup server to put in things like tape or other disks. This allows our data center, our VMware data center, to communicate with backup servers to offload these backups. You can enable the change block tracking, which is faster. It's basically incremental backups, only copying the blocks that changed since the last backup. Any questions? Okay. I'll make a video of this. Wait a couple minutes, and then we'll do DRS. 75%. Upload this video. Chapter 9 in the 174 playlist. Made for kids. Take about, less than a minute to upload. Okay, that uploaded. I can delete that. And now let's do chapter 10. Okay, there we go. Chapter 10, Vsphere Drs. As you see, there is only one section, so this won't take too long. The Vsphere DRS will take your computing capacity across a collection of servers into a logical resource pool. It allows virtual machines to be used within the predefined rules. So all the resources that are provided by each host now is just merged into one. Of course, it works best when vMotion migration requirements are met. It can be used for load balancing. Definitely good idea to have shared storage, because they'll need to, since we are sharing all our resources across all hosts, everything including storage should be accessible to all. You can set this to fully automated so that vSphere handles all this for you, or you could manually or partially if you want to work with it. And you can also set how aggressive or how conservative you want the migration to happen between systems. The vRealize Operations Manager will combine data and predict future demand and determine when a hotspot will occur. By doing this, it will handle when to move a virtual machine to another system, to maybe another system stronger, has more resources and will be able to handle more. So let's move it that way. Or, hey, let's provide more RAM because at about 8 a.m. is when there's a lot of logins. So it does that for you, so you don't have to do it. You can place the swap files in either where the virtual machine resides or at a different place, which is important again because virtual machines may be moving around all this shared resource, and you need everything to be accessible as it flows from system to system. You can say how many hosts or how many virtual machines will be on a host or separated. If you're going to have VMs that are communicate heavily with one another, then it's more ideal to have affinity rules versus anti-affinity. So for example, your DHCP, your DNS, your Active Directory, those three tend to talk a lot to one another. So it's best to put them in an affinity rule. All right, so you can define them by host groups, just like I said, the three that I just mentioned. Virtual machines can belong to multiple VM groups. So you can play around with what configuration works best for you. A VM host affinity rule will say the relationship between that VM's DRS group and its host DRS group, and that can either be required or preferential. And then you can specify some options like this has to run on host in the group, or must not run, or should or shouldn't. Here's a affinity rule preferential. It's a soft enforced, so it can be violated if necessary. For example, we have in group A 1 VM and in group B 2. It's not an enforcement, so we can move it over to the other group. Whereas required will prevent the VM from running anywhere else. Like, let's say, based on licensing. You can configure how automated this will be for the entire cluster. So here's the VM override. When you add or move a host into a DRS cluster, you can actually keep the resource pool of wherever it came from. Those are not lost. So you don't have to reconfigure that. It'll move with it. There is a summary tab that'll provide you information about DRS. So you can see if everything is fully balanced between the DRS cluster, or if there's something that needs to get adjusted. You see how much power, or the sum utilization of CPU, for example. In this case, we have one system that is being used and the other one who's not. DRS can give you recommendations. So you don't have to figure it out all on your own. You can hit the run DRS now, and it'll tell you some recommendations to do, and either you could override or you could apply them right away. So for example, in this case, it's telling us, it's suggesting us to move a virtual machine from one host to another to balance memory. Anything that goes on with events, they will get logged. So we can check that out later to see the state or review what happened. If you need to do any maintenance when in DRS, you'll definitely need to enable maintenance mode. You won't be able to power on or migrate any VMs to that host while it's in maintenance mode. but it does allow a DRS to handle migrating any VMs out of the way so that you can do whatever you need on that specific host that will be taken into maintenance mode. With removing, again, you have to take it into maintenance mode to ensure everything is cleared out. Then you can remove it. And then the overall resources for that cluster will decrease once it's out. The resource pool will stay. It is possible to disable DRS. It is not something that's turned on once and stays on. You can turn it off later. All the resource pools will get removed. All the affinity rules won't be reestablished, so they'll have to be turned on later. Any licensing issues may need to be dealt with. But if you want to avoid losing those resource pools, do a snapshot. If you're looking at improving virtual machine performance, here is kind of a way for you. You could start by having a DRS cluster and then having multipathing, use NIC teaming, moving up the chain in order to improve VM performance. And you notice a lot of these are network-based because most of our VMs, especially in these scenarios that we're talking about, they're not running on one VM, or sorry, they're not running on one host, they're running on multiple hosts. Vsphere HA and DRS don't seem to play well together. So it's really, if you want to use HA, then you'll probably go well with fault tolerance versus DRS. Cool. Any questions? Okay, well, as always, there are labs to do in Canvas. And if you get stuck on anything, feel free to say so in Discord. So with that, I have no reason to hold you hostage, so I will stop the recording and end the live stream.